This video will go over section 8.4, which is on solubility again, but it's focusing on the effects of temperature and pressure. So first, let's look at the temperature's effect. So solubility depends on temperature, and it increases as temperature increases for most solids. And so this graph here shows you temperature on the x-axis going up from left to right. And on the y-axis, we have the solubility, which is the amount of solute in grams that can be dissolved in 100 grams of water. So it's for the solubility in water. And so you can see that as temperature increases, going from left to right, the amount of grams that can be dissolved in 100 grams of water is also increasing. All the curves are moving upward, right? NaCl is fairly flat compared to the others. However, we know that when we put salt in water, it will dissolve better when the water is warm than when it's cold. And so for other solids, you can see that it's even more true. Increasing temperature really helps the solubility. So you can put much more substances solid in water when water is warm than when it's cold. For gases, it's the reverse. The solubility decreases as temperature increases. So same type of graph with temperature on the x-axis going up from left to right. And then the solubility of gases in milligrams of solutes per 100 grams of water, going up as you move up the y-axis. And so you see the curves this time are bent the other way. They are going down when the temperature increases. For example, oxygen, you can dissolve less and less as the temperature increases. Carbon monoxide, nitrogen, all gases behave this way. You can dissolve less and less gas when the temperature of the water is increasing. So now let's look at the effects of pressure on solubility. And there is a law for that. It's called Henry's law. And it says that the solubility of a gas in a liquid is proportional to the partial pressure of the gas above the liquid. Remember how the partial pressure of a gas is the pressure of just that gas. And so gases are above liquids, and the higher the pressure of the gas above a liquid, and the more you can dissolve in it. So the higher the pressure, the higher the solubility of a gas in a solvent. So it's like you can visualize this as you're kind of pushing gas inside the liquid if you have more gas pressure above the liquid. And solubility increases. Let's look at an example to illustrate that. This is showing you a molecular level of water and carbon dioxide. The dark molecules here are CO2, one carbon surrounded by two oxygens, which is a gas at room temperature. And so when people are manufacturing all kinds of carbonated beverages, the way to do this, to have the carbon dioxide dissolved in the soda, you are putting a lot of pressure of carbon dioxide above the liquid, above water, and that will help increase the solubility of CO2 in the liquid. So higher pressure of CO2 allows for higher CO2 solubility, and then you seal the can this way, and then you have a lot of CO2 dissolved in the liquid. Now, when you're opening the can, you are releasing the pressure. The pressure now is not high anymore, it's just atmospheric pressure. And so this lowers the pressure of CO2 above the liquid. And so the CO2 inside the liquid liquid will be less soluble, and this will make it come out of solution. So a lower CO2 pressure will create a lower CO2 solubility in the liquid. And so you will see those tiny bubbles forming inside the liquid and move up and escape in the air. And so that's the CO2 that is less soluble and escaping the liquid and go back into the gas phase. So let's practice this learning by checking here. So why could a bottle of carbonated drink possibly burst, which means explode, when it is left out in the hot sun? So I want you to think about it before you hear the answer. So we have a bottle of carbonated drink sealed, and it's left out in the sun. So the temperature will increase, right? Like for example, in a car, it can get very, very hot. So temperature will increase. When temperature increases, the solubility of gases decreases. So this is the effect of temperature. Solubility decreases when temperature increases. So the gas will want to get into the gas phase above the liquid. And so you will accumulate gas above the liquid. And the more gases in that tight space will increase the pressure, and that's why the bottle could burst. Oops, sorry, this way. The pressure in a bottle increases as the gas leaves solution because it becomes less soluble at high temperatures. And so as pressure increases, the bottle could burst. It's like also putting a can of an aerosol can into, for example, a fire pit. It never do that because it's well sealed, but there is gas inside the can. And if you put it like in a fire, it will get very hot. The pressure will increase a lot inside the can, and it can explode, and that can be very dramatic as it explodes. So another question, why do fish die in water that is too warm? So think about it. So when the water gets warm, it means the temperature is increasing, like during summertime, temperature can get much higher. And when temperature increases, the solubility of gases decreases in the water. And fish need to breathe oxygen just like us, except they take the oxygen that is dissolved in water. And if the temperature increases, the solubility of oxygen in water decreases. And so that means there is less oxygen available for fish. And so they can die if the water is too warm, because oxygen gas is less soluble in warm water, and fish cannot obtain the amount of oxygen required for their survival.